Using Millman's theorem, find current through load resistance RL. Okay, that is IL through RL for the network shown in figure. So here how many voltage sources are connected in parallel? So Millman's theorem states that if uh, two or more, okay, voltage sources are connected in parallel, okay, they can be converted into single voltage source. So this is a single voltage source. This can be converted into this format. Okay, single voltage source V with R. Okay, R impedance or single impedance Y. Anything you can write or Z. So how to convert using Millman's theorem? What is the Millman's theorem? States that Millman's theorem states that, okay, in any network containing more than voltage sources, that is E1, E2, E3, you can extend dot dot dot. Okay, even here only three are given. If three voltage sources are connected in parallel with internal resistance R1, R2, R3, because in our problem it is a DC network, so we don't have impedance there. Resistance R1, R2, R3, they are connected in parallel. They can be replaced by, okay, that can be replaced by E is equal to single voltage source and single resistance, where the value of E is equal to, okay, where the value of E is equal to, we can write, okay, only resistance. No, I will write one more formula if you want. You can write the single voltage source value is E is equal to, okay, uh, E1 by V1 by R1 plus E2 by R2 plus E3 by R3, whole thing divided by 1 over R1 plus 1 over R2 plus 1 over R3. This is the value of effective this voltage E, and Z is given by 1 over 1 by R1 plus 1 by R2 plus 1 by R3. So this is the value of Z, and that is the value of E if it is a DC network. So let us solve this one by one. So if you want, you can find, since it is resistance network, 1 by R1 is 1 by 2, 0.5, 1 by R2 is 0.33, 1 by R3 is 1 by 4 is 0.25. And now we can calculate this. Okay, so you can take a calculator. I will show you how to do this. So take the calculator. Okay, so I'm going to do like this. Clear it. You take this, okay, numerator and denominator. So again here we have, okay, here we have uh, E1 by R1. E1 by R1 is nothing but E divided by reciprocal of R1. So I am going to give here, see the polarity, plus minus plus minus plus minus. So all the currents are going. If I convert this voltage source into current source, the current source will go upwards. Okay, the current source will go upwards. Here also, if I convert this one to current, will go upwards. This also current will go upwards. All the currents are going to add. All the currents are going to add up. So now I'm going to write voltage value is what? 10 into 2 inverse. Okay, 10 into 2 inverse plus 20 into 3 inverse plus 30 into 4 inverse divided by, divided by 1 by R1 plus 1 by R2 plus 1 by R3. That is R inverse plus R2 inverse plus R3 inverse. Is 2 inverse plus 3 inverse plus 4 inverse is equal. You're going to get 17.69. 17.69 is the, okay, this is a voltage value, effective voltage. You have to write volts. This is the value of E. We got, using this formula, we got this, or you can write this also. Both are correct. Okay. Now I have to find out what is the value of Z, or equivalent resistance. So it is given by reciprocal of R1, reciprocal of R2, reciprocal of R3, whole you have to take reciprocal. So for that, again you have to take the calculator. Actually here denominator is there, no? So same thing you're going to get. So once again you do, I can write 2 inverse, okay? Can do like this also. 1 divided by 2 inverse, 2 inverse plus all 2, 3 inverse plus 4 inverse. You'll get 0.923, this answer. Okay. Or you can also do 2 inverse plus 3 inverse plus 4 inverse is equal to, you put after that answer inverse. You can do like this or you can do like this. This is similar to this, so you can follow this. So we got 923, it is a resistance. So this portion is Millman's equivalent circuit. Which portion? This portion. This is, we converted the parallel voltage sources into single voltage source E and single equivalent resistance R. Okay. In general R in general it is impedance, but here it is given a DC network, so you can write R also, where reactance part is 0, only resistance is there. So after that you can consider this is also R only. Okay, you can write this as a R, it is a E. After that, what is the current through this one is given by I is equal to voltage value divided by R plus RL for DC network. Okay, for AC network, Z plus ZL. So voltage value how much we got? 17.69 divided by R value is we got 923 plus RL is, you see the RL value in this circuit. This is the load. This portion we converted only this portion. We converted only these three portion into Millman's equivalent circuit. So same RL load resistance you have to connect here. After that, we remove 10, no? So we have to write 10 here. So if you calculate, you're going to get 17.69 divided by here. Okay. We calculate now 17.69 divided by, so you can better you can take because some students they will make mistake, 17.69, or you can take 17.69 divided by open bracket and you have to give sum, because in the denominator if plus or minus is there you have to write within a bracket. But if you follow this fraction this type, then no need to write bracket. You can write Z is how much? 0.923. Okay, this is R value is 0.923, 0.923 plus 10. Here it is wrong, so this you have to convert. This is 0.923. Okay, so is equal, press is equal to, if you click 1.619 will come, 1.619. So this answer is correct. Okay, IL is equal to, IL is equal to 1.619 and unit of current is equal to so current through this resistance is equal to this. So let us do one more problem. Okay, where the battery polarity is changed. Okay, very very important. So using Millman's theorem, find current IL through RL using Millman's theorem. So here also, instead of AC network, they asked DC network. How many voltage sources connected in parallel? Three voltage sources are connected in parallel. This is E1, this is R1, this is E2, R2, E3, R3. So we can write formula as I can convert this into this network. I can convert three parallel voltage sources into single voltage source and single resistance. Then what is the value of this single voltage E and single resistance R? So formula is E is given by, okay, E1 by R1, that is the current. If I convert this voltage source into current source, voltage by resistance. And if I convert second voltage source, E2 by R2 and E3 by R3. Okay, these are the three currents we are adding. So now let us see the direction of the current. It is minus to plus, so current will go upwards. This is minus to plus, this current will go downwards. This is minus to plus, current will go upwards. This current will go upwards. Current go upwards. Okay, now what happens, you are in the formula, okay, in the formula this should be negative. In the formula the current should go, you have to subtract the current, so this is plus, please note down. Now since the current is minus to plus upwards, this is also minus to plus upwards, but this is minus to plus, plus is down. Observe here, plus is up, plus is up, this is plus is down. So two currents are going upwards and one current is going down. This in parallel, if currents are going same direction, you have to add, otherwise you have to subtract. This one is actually now minus, this is minus. Okay, so this should be minus, plus I'm converted into minus because this current is going downwards, divided by 1 by R1. Resistance values and all, no, that will not change, only current values you have to change, and equivalent impedance will be, resistance will be 1 by R1 plus 1 by R2 plus 1 by R3 only. So now using this we can find the answers for this. Okay, let me do this. Okay, what is the value of V1? 20. Okay, first I will write this. Okay, better use this type of calculator for exam, so you are not going to make any mistake. So it is E1 by R1. E1 is actually 20 into divided by R means 2, 2 inverse. Okay, it is nothing but 20 by 1. Okay, sorry, 20 by 2. 20 by 2, that current will go upwards, and this is current downwards. See here, minus is at the top and current will go. So you have to subtract this current value. So minus you have to write, very very important. This you are going to mistake. You are going to make this 40 by 4 inverse. That is nothing but 40 by 4, and again this third 50 by 5 is going upwards, so it should be plus 50 into 5 inverse. The denominator, we have 1 by R1 plus 1 by R2 plus 1 by R3. This is nothing but R inverse plus R2 inverse plus R3 inverse. So R1 is 2 inverse, R2 inverse is 4 inverse, R3 inverse is 5 inverse. This is 200 by 19, which is 10.52. Okay, which is 10.52. 10.52 volts. And the value of R is, okay, value of R is 1 by this portion, only denominator portion, 1 by R1 plus 1 by R2 plus 1 by R3 reciprocal of that. So that you can calculate using formula. So the value of R is given by, I will write one more time. The value of R is 1 over by R1 plus 1 by R2 plus 1 by R3. In terms of impedance, it is equal to, okay, 1 over y1, 1 over y2, 1 over y3 means this is 1 by z1 plus 1 by z2 plus 1 by z3. 1 by z1, 1 by z2, 1 by z3 because it is admittance. In terms of impedance, yeah, internal impedances are z1, z2, z3. So it is y means reciprocal, or in terms of admittance, it is g1, g2, g3. It is g1, g2, g3. G is conductance, okay, E1, G1, E2, G2, E3, G3. So G means 1 by R1. So reciprocal of resistance is conductance. E1 by G1, E1 by R1, E2 by R2, E3 by R3, and G1 means 1 by R1, G2 means 1 by R2, G3 means 1 by R3. So same we are writing here. Okay, now what is the answer we have to calculate? So it is, what are the three resistance? You can write one numerator 1, this one, divided by R1. R1 is 2 inverse plus 4 inverse plus 5 inverse is equal. So it is 1.05. 1.05 is the answer. It is 1.05. Now this is the equivalent Millman circuit. Now whatever RL is there now, this RL you connect here. Then the value of current in this circuit. Value of current in the circuit is, in the simple circuit, voltage is E. R plus RL are in series. R in terms of Z means Z plus ZL. Or if you are getting confusion, IL is equal to E divided by R voltage V also you can write. You can write anything, E or OE, both are same. So R plus RL, it is 10.52 divided by 1.052 is Millman's equivalent resistance, and RL is 9.9.4. You're going to get approximately 10.52. Let us do now. It is 10.52. Okay, divide by, I told no, if you are not using this one, then you have to use bracket. 9.4. Okay, on 10.02 divided by, you have to use this one. If you are not using this portion, what is the answer? You can see it is 2630 divided by 2613, approximately equal to 1.000. Okay, so answer is 1 amp. Or you can use this also, 10.52 divided by, okay, 1.052 plus 9.4. So in both the cases, answer is 1.00. So answer is 1 amp. You can write answer as 1 amp. So it is very easy. Easily you will get 8 marks. If they ask DC network, you can easily solve. And this one, don't confuse. In general, we can write impedance E1, Y1, E2, Y2, E3, Y3. And many students will make mistake while writing R value. They will forget it is reciprocal of this portion. They will calculate only 1 by R1 plus 1 by R2 plus 1 by R3. they put that value here. So it is a mistake you're going to make. So it is 1 by R1 plus 1 by R2 plus 1 by R3. So you have to calculate R inverse plus R2 inverse plus R3 inverse, that whole inverse. Okay. So here you're going to make a mistake. You double check this value in the exam. Thank you.